Okay, hello again. John here. Welcome back to Osaka Makerspace. And today we're going to continue on our cat toy project. So, a quick recap. Last time we went over our schematic and we kind of breadboarded out our main components. And I have now got us onto the next step just before the starting of this video. But don't worry, I will cover all the points that have happened in the meantime. So, first thing we want to do is we want to test our circuit, right? So, make sure I got all the connections nice and firm here. So what I did just before starting this video was I created a short little program and I installed it onto the DigiSpark. And I will show you that program now. We'll move over to a screen capture, and here it is. Okay, so now we've seen the program, and so that has been loaded onto the DigiSpark. It's just a very little small test program. And so what we're going to do, I mentioned before that I'm still trying to figure out the solution for power. If we go back to our first page here, right, we're going to have some type of an AC adapter that's going to connect up to all of this. And I had to look through the AC adapter box that we have here, and I couldn't find anything that's perfect. So probably what I'll do is I'll go and I'll just buy a standard maybe 1 amp 9 volt AC adapter from the store, and we'll install it later. And so for now, in the meantime, we will stick to the bench power supply. And so, plus this will allow us to test out our design after everything is constructed before we invest in a power supply, just to make sure that we don't have too much electricity going through it and making it harder for it to be stopped by the cat. We don't want to injure the cat with this thing. And if somebody walks by and gets hit in the leg or something accidentally, we don't want to injure any people as well. Okay, wait a second. Let me switch this out. So I had actually hooked up a 9 volt battery to this first, and the draw on power was a little bit too much for the 9 volt battery. Maybe it's going dead or something. I don't know. The power is on that. We can actually test it simply by hooking it into our component tester. It'll tell us the voltage on it. And oh yes, the voltage is extremely low. It's actually 5.7 volts right now. So that is a nearly dead 9 volt battery. So that's probably why it was turning off the DigiSpark every time it tried to run the motor at the same time. So an AC adapter will prevent those battery related problems. So let's not go through the battery connector like I was doing earlier during my testing, just because it is going to be a little bit weaker of a connection. It might come undone, so we will just hook directly in here. Okay, and let's make sure that we keep these sufficiently separated. We want to short this out and damage my power supply. So let's see, how can we keep these apart? It's currently not turned on, so it's not a big deal, but maybe that'll be okay. If I stick a battery in between them, that should be alright. Okay. So let's get this turned on. And so what this program does, as I've explained before, it simply turns the motor on, turns the motor off. That's all we should see. And then I'll tell you what kinds of values we're getting on the power supply over here. So here we go. Boots up. And there we go. On, off, on, off. No problems. And so it looks like at 9 volts, when the motor is moving, we're at 0.76 amps, which is 0.68 watts. And when it's off, we're at about 0.02. Oh wait, did I make a mistake there? 0.07, 0.08 amps with the motor running, 0.02 or 0.019 amps when it's off, which is 0.17 watts. So very low power. It's an excellent microcontroller, in my opinion. It uses very little electricity, and even when the motor's running, it's still really low. And then, so a very good possibility this thing will be stopped by the cat, hopefully not with a rope around its neck or something, but oh yeah, it's very simple to stop. It requires very little effort. And it jumps up to 0.4 amps, which is, looks like it's about 3.5, 3.9 watts of power under full load with the motor being stopped. So again, that's not too much, and I think it is it's definitely well within what this motor can handle. So I think that's pretty good so far. Now I hope this motor is not a little too heavy, since it's going to be in the top of our tower. I hope it's not too heavy and it causes it to fall over, but we can always correct that with a little bit of weight added to the bottom. That should be fine. Okay, so what's our next step? Our next step is to attach our sensors and see if we can get the sensor to activate the motor, right? And to do that, I have a couple of ideas of how we can connect these sensors. I did a little bit of Googling, and there's a very nice library written for the Arduino, which you can find on arduino.cc, and it makes a 4-pin ultrasonic sensor into basically a 3-pin. It'll work on 3 pins, and so that's nice. So that cuts down the number of pins that we need, which will also enable us to have more pins on our Digispark in the future if we need to. And as well, I have some theories about how we can possibly connect them at the same time in the program. We will have to do a little bit of experimenting, I think. So before we start experimenting with that, let's try to reduce our variables, right? We want to test one variable at a time when doing something for best results. So we're going to just connect one first and make sure that that works, and then we'll bother with trying to connect a second one. We don't want to try to connect 2, run into problems, and then try to figure out if it's because it's the second one is also attached, or if it's because we didn't properly attach either of them to begin with. So we'll start with just one. So that's next. And so what we're going to need, according to the new ping.h library, we're going to of course need our VCC, we're going to need our ground, and then I believe all we need is the, what was it? Possibly we need trigger and echo. Actually, I'm going to have to check that. Do we need them both connected to the same pin, or do we only need one pin? I think it's probably only one pin. But again, I will double check that just to be sure. Alright, so give me 1 second to double check that, and I'll be right back. Okay, so I checked that, and what it is, you have to connect both of these pins to the same pin on the Arduino. So that's what we'll do. And since we were just about to that part, I went ahead and I loaded up a sketch that will use one of the sensors, and hopefully when it is activated within 1 meter, which is about 3 feet for those of you who are unfamiliar with metric system, then it should activate the motor for 100 milliseconds and then turn it off for 1,000 milliseconds. And then as long as there's something within that range, it should run that loop. So this is my first time trying it. Let's see if it works. So first we need to connect. Let's see if I can find some good wires here. Perhaps I should have prepared those first. Oh well. Spend all your time preparing everything, you never get anything done. Okay, so something to remember here. When connecting your ultrasonic sensor, your echo sensors here, make sure that, let's see, I have these set for pin 0 right now. Make sure that you, if you're using a Digispark, then make sure you connect your VCC on the ultrasonic sensor to the 5-volt pin on your Digispark if you're using a non-5-volt parallel power rail for your motor driver, right? So if we look back to this schematic here, what we're doing here, right, this is 7 to 9 volts and it's powering the motor, and then we don't have it written down on here right now, but the Digispark is also being powered by this via a separate wire, right? And it can handle this power range, no problem. It can go, I believe, up to 20 volts. So that's not a problem for the Digispark. However, it would be a problem, I believe, for your ultrasonic sensors. You can't connect them directly to a 9-volt source, so you might blow it out. So what you'll need to do is connect it to the Digispark, and the Digispark should be able to provide it with the power that it needs at 5 volts. And I believe these are going to be sufficiently low power that you're not going to burn out your Digispark by trying to run a couple of those off of your 5-volt Digispark pin. Okay, so, and again, trying to keep everything color-coded. It might be causing a little bit of trouble for me here. We're just going to go a couple of non-red and black colors, but gray is kind of like black, so that'll be our ground. There we go, and that can connect to our regular ground here. And purple is red with just some blue mixed in, so that'll go into our VCC. Oh, you know what? Actually, I need a double female. Looky here, I did have these here. I thought I did. Okay, I may actually have black, but that's okay. I'm not gonna bother with replacing it right now. Okay, there's one. Ah, well, I went with black. I can't do that to you. Some people will actually flip out. All right, yellow it is. Just remember, this is okay, I could have done that another way, especially if I'm gonna hook my second one, but that's okay. This is just a single test. All right, so we should be good. I need to probably point this in a direction where I am not interfering to make sure that it's not activating before we're ready for it to. So, but first, let's quick look at the sketch that I made for this second test, right? This is the test of using the sensors with the motor being activated from the sensors. So let's do that now. Editing magic. Okay, so that was the sketch, and now we are turning it on for the first time. Please work, please work, please work, please work. There's some dust on here, hold on. Okay, please work, please work, please work, please work. Okay, it's turned on. Takes a second for a Digispark to boot. Oh wait, we got a motor activating. Is it because there's something in the way? Ah, we have problems. Something's wrong. It's time for troubleshooting. But it is activating the motor how I wanted it to. A very short burst, and then a wait. A long wait. That's nice. But yes, clearly we are not doing something correct with our sensor. It might be the new ping library that we're using improperly. It might be this 3-pin setup. What we could possibly do, what if we unplug our trigger just to see what happens? Still no good. What if we unplug our echo? Still no good. Okay, what if we unplug the entire thing? Still no good. Okay. So we have a problem that is beyond our sensor, it would seem to me. So back to the drawing board. We'll stop here for now, and I will discover our problem. I will correct the problem, and then we'll come back next time and I will explain what the problem was and how I corrected it. Alright? So I'm not a professional programmer. Like, I kind of know how to program, but I don't do it every day, and so I often forget things. And so it can take me a while to make even simple programs, and especially to make simple programs work. So instead of perhaps taking an hour to figure out a simple problem and subjecting you to that torture, I will figure it out and then I'll get back to you. Alright? Okay, that's it for today. Thanks for watching. We'll get back to you, and this will be working. See you next time.